Okay, this is section 11.7, geometric probability. You may have had some probability in the past, but the thing I like about geometric probability is that we can visualize almost all of the things that we're going to talk about as far as probability goes. So let's first talk briefly about what probability is. It's the ratio of successful outcomes to total possible outcomes. That is so important. It's successful times to the total amount of times. It's the number of times the thing that you want happens to the number of ways it could have possibly happened. Okay? So if we look at the likelihood of rolling a 4 or a 6 on a regular-sided die, we're going to take the successful, we're going to take the successful number of outcomes, so success divided by total, and that's going to equal, let's see, a 4 or a 6 on one regular-sided die. Well, you can either roll a 4, that's one option, or a 6, that's 2. So we've got 2 out of 6 total possible rolls, right? 1, 2, 3, 4, 5, or 6, and that reduces to 1 over 3. So the probability is 1 over 3. It will always be between 0 and 1. And we could convert that to a percentage, right? 1 over 3 would be about 0.33, which would be about 33%. So probabilities can always be written as a percentage. Remember that it's much different than odds. Odds, we say something like, the odds against are 3 to 2. That's very different than probability. So, but we will only focus on probability as to not get confused. Okay. This next example, this game show problem, I'm going to leave that for class. It takes a bit of explaining and visualizing and stuff, a bit more than I can do here. So we'll look at that in class. Let's look at length and probability. This is something that will come up on the quiz. Let segment AB contain segment CD. If a point K is chosen at random, the probability that it is on the segment CD is the ratio of the length of CD, blah, 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 blah. Let's draw a picture. Let's draw AB. Okay. A, B. Okay. And then somewhere in here is segment CD. Somewhere in the middle. Doesn't really matter where it is. Okay? And then what we're kind of imagining here is that we randomly pick a point K somewhere on the line. Come on, load, you stupid thing. Okay. We randomly pick some point K somewhere on the line. We don't know where it is. I happen to put it a little bit to the right of D. We don't know where it is. So, the probability that K, so we're going to write this as like this, K is on CD, segment CD, that probability is going to be the length of CD divided by the length of AB. And if we think about it, it fits right into what we just learned about probability. I'm taking the good, what I want, to land on CD, and dividing that over the total number of outcomes. Well, the number of outcomes in this case is the length of AB. That's my possible places where K could land. So probability that K is on CD, CD over AB. Let's look at some examples. Okay, BC. Excuse me. I want to figure out what's the probability that if I pick one point randomly between A and E, that's my limit here, is between A and E, what's the probability that I'll land on BC here, between B and C? Okay. Well, to do that, we've got to figure out how far BC is. BC looks like 2, 4, 6 units, so it's going to be probability of landing on BC is going to be 6 divided by the whole thing, and the whole thing is 16 units, right? -8 to +8, and that reduces to 6 over 16 is 3 over sure why it's loading so slow. I apologize for that. But we could do the same thing for BD. BD looks like 6, 7. The whole thing here is 10 units. Alright, so BD, the probability of landing on BD would equal 10 over 16. And you guys get the idea. 10 over 16 reduces to 5 over 8. And notice that these are fractions between 0 and 1, right? Every time we could convert these to a percent. And that's kind of how we should think about it. 3 and 4, I think you guys could probably get the idea. I want you to do 3 and 4 on your own, and I'll bring up the next picture here. The cat is laying on the iPad. Okay. Probability and area. Now, so this, oh, hold on. There. Okay. Probability and area. Wait. Okay. Let's see. What's the deal here? Okay, I apologize for this. I'm not sure why it's not loading. If it doesn't load in the next about 5 seconds.